Hello everyone and welcome to Huawei Connect. Today, I'm honored to share with you some ideas about how to efficiently develop cloud-native applications. As we all know, the service architecture has evolved from the monolithic application to SOA, microservice, and cloud-native. In recent years, serverless application development has become an important branch. How can we help developers focus on service innovation and implement out-of-the-box development to simplify the development of cloud-native applications and reduce the learning cost? How to quickly iterate a service at low cost is now a pressing concern. Huawei Cloud provides DevStar, a one-stop serverless cloud-native application development platform for developers. Based on rich industry application templates, developers can quickly build industry application code with a low threshold for free. In addition, a complete toolchain for continuous delivery of cloud-native applications can be quickly established. Using DevStar, developers can easily perform development activities in teams through the unified software delivery management view. Examples include environment management, application build and release, and online development. Furthermore, developers can build, release, test, and deploy code quickly. Now, I'll show you how to use Huawei Cloud DevStar to develop serverless cloud-native applications.
Hi everyone, it's great to introduce DevStar. I'll show you how DevStar can help developers focus more on service innovation, making cloud-native app development simpler with a lower learning costs. More importantly, DevStar can help development teams achieve serverless R&D architecture and systems. On the template center page, DevStar provides various industry app templates, for example, templates for OCR application and for facial recognition application. DevStar also provides industry application templates for microservices. Today, I'm going to show you an OCR industry app. First, choose a DevStar OCR template to implement an OCR-based ID identification app. Select this template, select the developer app to proceed to the Create App page. A DevStar app belongs to a DevStar project. A project can be seen as a product line, and a product line has multiple apps. To save time, the app being created belongs to a project I have already created. Enter the app name, say OCR identity recognition, then description, say identity recognition. Click View Deployment Architecture to check out the typical deployment architectures for serverless cloud-native apps. Click Create Now to create the app. Now we come to the initialization page. DevStar helps create a complete toolchain for continuous delivery. The toolchain is already created. As you can see, it contains a code library. The code here is the code in the OCR template we just selected. There is a pipeline as well that developers can use for build and release. And now we can start developing the app. Typically, we just open an IDE, clone the code locally, and submit it to the remote warehouse. And then we're ready to test and deploy. But before we do that, let me show you something. DevStar provides a powerful and unified app development view for developers. Developers can develop, test, and deploy apps just using the browser page. On the left, there is a menu for online development. Click it. Developers can do coding here. And then there is also an app deployment view where developers can test and deploy apps. DevStar has created 3 typical environments for most applications, which is development, pre-release, and production. In each environment, there is a section of dependent cloud services, while developers can quickly provision the cloud services that the app depends on. Take our OCR app, for example. It depends on the OCR text recognition service of Huawei Cloud, and the developers can easily provision the service here. They can also click the link on the right to view price details. In the software release library on the left, developers can easily view the software packages generated during continuous delivery iterations. Now let's check out how to develop an app online using DevStar's unified view. Click Online Development on the left. There is an option of Experience Online Development for free. Click it. It's a free trial, so the IDE instance is not permanently stored. Click OK. The online IDE is being loaded. Okay, the project has been loaded into the online IDE instance. Click to view full screen. The experience here is very close to the local IDE we normally use. Check out the core Java code of the application. Say if we change the region name of the OCR service, click Source Control on the left, we'll see the file was modified, added to the temporary storage area, input commit message, and then submit. Open the online IDE terminal. Okay, here is a reminder that there is one commit to be pushed. Push it. And the latest code modifications will be pushed to the remote warehouse. Exit full screen. And then, actually, we are ready to start deployment. At this point, we can directly deploy the latest code. But to demonstrate the DevStar's end-to-end capability for continuous delivery, let's look at the overview page first. There is a build and release section. Well, developers can build and release latest code. Click Execute. So our first build and release is done successfully, which is actually a complete code compilation build and release. In the software release library, we can see the software packages we just built and released. Next, we deploy the app. Click App Deployment on the left to return to the deployment view. Click the red button on the right. As mentioned earlier, functions are a key component of the serverless architecture, enabling developers to focus more on their business logic code. We didn't change the name of the function, so we don't need to change the function entry point. In the software package section, we have already built a software package. So click Use Existing Software Package to deploy the package we just built. We can also create a new software package. In most cases, developers can modify the code and perform end-to-end testing and release. This is when we need to create a new software package. So we select using existing software package, click OK. Our function is being deployed. Okay, the deployment is done, and we click to get back to the deployment view. A temporary access address has been generated. The newly deployed function and its resources are displayed below. Then we copy the address to check out the app we just deployed. The app is on. Now we can do a demo with a sample ID card.
OK，大家可以看到，其实我点击了一下识别，然后其实
Click
我
Identify.
们已经成功的通过
The
Huawei 的
ID
OCR
card
的
is
服务去进行
recognized
了这个样例的身
successfully
份
with the
证的
Huawei
图片的
OCR
这个文字
service.
识别。好了，到现在为
By
止呢，大
now,
家应该非常熟悉，
you should
就
know
是
how to
如何
use
通过 DevStar 去
DevStar
快速的
to
构建
quickly
serverless
build a
应用
serverless
并
cloud
按
native
照
apps
应用的开
and
发、测试
do
和实
app
现。那么在实际的开发场
development,
景当中呢，其实
testing,
绝大部
and
分情况下，
deployment.
应用的
In
开
real
发其实
scenarios,
需
most
要
apps are
内中
developed by
多个成员的
multiple
协作
team
开发。那
members.
么实际上 DevStar
DevStar
也
also
支持
supports
随时随地的在线协同
online
应用开发。
collaborative development
那么这个时候
anytime,
呢，
anywhere.
我给大家演示一下
Now,
DevStar 是
let me
如
show
何
you
去
how it
实
works.
现团队协作开发的。那么在右上角的项目菜单
Select
下
a
面，我们
project
选
from
入到一
the
个项目，
project
然后点击
menu
右
at the
侧的
top right
成
corner
员管理的图标，那么
and
就会
click
进入
member management
该项目
icon to
的
enter
成员管理的界
a
面。
page
那么在这个界面呢，
where
大家可以看
I
到
can
我可以
invite
去邀请当前客户
IAM
下的
users
IAM
under
用户
the current tenant
协同开发
to
该项目下的所有应
collaboratively
用。
develop
那么
all
同时
apps
呢，我
under
也
the
可以去
project.
邀请华
I
为
can
的
also invite Huawei
账号
main accounts.
去协同开发该项目下的所有应用。那这个时候呢，我点击一下邀请
Click
IAM 用户
invite
的
IAM
按
user
钮，去演示一下
to
如何去邀请当
bring
前租
on
户下的一
board
个
an
IAM 账号。
IAM
那
account
么这个时候大家看到
under
我
the
当前
current
这个租
tenant.
户下有一个
As you can
IAM
see, the
账号，
tenant
所以
has
我
an
勾选项，
IAM
然后点击确
sub-account.
定。那这个时
Check
候呢，
it
其实就
and
是我
click
把这个当前
OK
租户下
to
的这个
invite
IAM 用户
the
去邀请到
IAM
这个项目里
user.
面。那么他作为一个开发人员
The
呢，他其
user's
实
role
可
is a
以去协同
developer
开发
who
该
can then work
项目下的
on
所有应用。
developing
好了，现在
all
我已
apps
经
under
使
the
用刚
project.
才被邀请的
Now,
IAM
I
账号
already logged
登录到
into
了
DevStar
DevStar。那
using
这
the
个时候大家可以
invited
看到，
IAM
因为我
account.
是这个项目的
As
开发
a
人员，那么
developer
我
in the
可以去
project,
进行
I
这个
can
项目
do
下面应
routine
用的日常的
development
开发工作，比如
activities
说在线开发，
such as
然后
online
应用部署，
development
然后
and
同时
app
也可以
deployment.
查看
You
这
can
个
also
项目下的
view
应用的
the
来源
software
账户。
release
上面
library
就
under
是
the
大家介
project.
绍的华为
All right,
DevStar
this
和
is so
面
much
向
about
开发者的
Huawei
一站式
DevStar, a
serverless 云
one-stop
生应用开发
platform
平
for
台。那么
serverless
在未
cloud
来呢
native app
，DevStar 会
development. In the
提供越
future,
来越多
DevStar
的
will
丰
provide
富的
more
行业
industry
的应用模板，
application
鼓励
templates to
我们的
help
开发者
develop
呢
cloud
以更
native
低的
apps
成本去开
at
发原生应
lower
用。
costs.
In addition, Huawei Cloud provides developers with various powerful tools for developing cloud-native applications. Developers are the key to enterprise cloud application. Huawei Cloud provides various tools to help them develop cloud-native applications. For example, Huawei provides API Explorer and SDK based on various open APIs. API Explorer is a platform for developers to quickly search for and debug open APIs. Today, I'd like to introduce 3 new developer tools: Terraform Explorer, Huawei Cloud Toolkit, and CLI. Using Terraform Explorer, you can easily design and orchestrate cloud service infrastructure description online and in a visualized manner. Developers' daily work is concentrated in the IDE. Through Huawei Cloud Toolkit, or HCT for short, developers can easily search for and view OpenAPI documents online. With the help of the powerful intelligent code assistant, OpenAPI SDK code can be automatically and intelligently completed, significantly improving the development efficiency of cloud-native applications. The CLI is a convenient command line interface for script developers and O&M engineers to operate Huawei Cloud services. Next, I will show you how to use these 3 tools to manage, monitor, and stop Huawei Cloud resources.
How to use Terraform Explorer to quickly create an ECS. Open Terraform Explorer, click All Products at the top left corner, and select the Huawei Cloud Compute instance under ECS. Resource details are then displayed. Cloud Shell on the right is loading required dependencies. Now the loading is done. Next, fill in several mandatory parameters. First, AZ name where the ECS is located. Here we use the Beijing AZ, CN North 4A. The second is the name of the ECS. Name it as you want. The next one is the ECS spec. We use the most basic spec for general computing as a 6.small.1. The fourth parameter is the image name. We use Ubuntu Ubuntu, so we fill in Ubuntu 18.04 server 64-bit. The last parameter is the VPC network ID that ECS belongs to. To save time, we've created network in advance. So we enter the network ID and click a preview to find all generated parameters in the command line on the left. Click execute. In the command line on the right, we need to enter yes for confirmation. Check to ensure the parameters are correct and then enter yes. Terraform is creating the ECS. Wait for a sec, and now ECS creation is done. Go to console to double check. Click console at the top left and select the ECS. We can see the ECS has been created. Then how to use Huawei Cloud Toolkit. Install the plugin first. Click Settings in IDE Editor, select Plugins, select Marketplace, and then enter Huawei Cloud in the search box. The first in the list is Huawei Cloud Toolkit. Click Install. After installation, click Restart IDE. The plugin is installed successfully. There are two tabs on the left and the right side. Open the tab on the left, and the message is displayed to prompt the login. Click the little man icon for AKSK configuration. Click Get Your AKSK to find a guide to obtaining AKSK. I'll show you how it works. Click Console on top right and click My Credential. There is an access key on the left. If you need AKSK every day, you can click Add. Here we have already added it. Return to plugin configuration. Enter AKSK and click OK to log in. Click the plugin tab on the right. Here we want to develop an app to monitor ECS server status with API. If things are abnormal online, an alarm will pop up in the console. Select Spring Initializer on the right, click, and then click Create a Local Project. Configure some parameters here, modify the artifact ID, and click Create. At the lower right, we can create a new directory to place the new project. Now the project is created. Click to open project at the current page. The project is loaded. Open the main function. Then we can see this is a Spring Boot project. Next, we'll look up ECS service status. Click the tab on the right for API search. Input a list server. There is an ECS interface to list the status of all ECS servers. Click it to view detailed information, which includes URL, request parameters, and return parameters. Okay, make the Spring function a real function. And I'll show you how automatic code supplement works. The API is called the list server detail. We enter list server here, and the first prompt is the interface we want. Click, the code is automatically supplemented. At the same time, a message is displayed in the lower right corner asking whether to import Huawei SDK dependencies. Click yes. All Huawei Cloud SDKs are now automatically imported. 3 parameters need to be filled: AKSK and project ID. Go back to My Certificate page. Click API Certificate on the left, select the project in Beijing, and copy the project ID. Here we have filled all the parameters. We have added a proxy configuration as well. If you need a proxy for the intranet, you can refer to the code here. Now let's run the program. And it's running properly. Check the return value of the API. It contains a service list describing the status of the services created using Terraform. There are many fields contained. To understand each field, we can open the API file. The return parameters section contains detailed information of each field. There are also return examples. To save time, some scheduled execution code has been imported. A checker class is also used to check the API every 5 seconds. Now let's run the program. As we can see, it's running properly, and all services online are normal. This is an example of using Huawei Cloud Toolkit to quickly invoke Huawei Cloud APIs. Now let me show you how to stop an ECS instance using Huawei Cloud CLI. Click Development Tools on the console, select the CLI toolset, and click Use Now. Help information is displayed to assist developers. Next, we run configure command to query default configuration. We can see region and token information have been imported for future use when we invoke Cloud APIs. Next, I'll show you how to use Huawei Cloud CLI to stop an ECS instance. Query details about the ECS instance first. The hCloud tool supports automatic supplement. This function is enabled by default in CLI. Click Tab to supplement the command. Here, all interfaces, starting with a list, are listed. Select the list server detail, and then we can query detailed information about ECS instances. As the return value is complex, we use some parameters for filtering. We put in --JSON filter in the command line to get the ID and the status of ECS instances we want. We can also get the status of ECS instances as well. Randomly select an ECS to see how to stop it. Automatic supplement can be done using Tab. We can also use the interactive prompt in CLI. Enter interactive parameter in the command line. Select the ECS service to be invoked, and then click to stop the interface. Since the region information has been configured, we just specify the queried ID. Use debugger parameter to view how the interface is invoked. Run this command, and we'll see the API is successfully invoked. Okay, query the status of the ECS instance we just stopped. As shown here, the ECS is shut off. Now go back to the Spring Boot monitor program, and we can find the information about stopping the instance.
Hello everyone, and welcome to Huawei Connect. Today, I'm going to talk about low-code development using Huawei Cloud AppCube. With AppCube, anyone can be a developer and improve efficiency. This presentation will cover 4 aspects. First, why does low-code matter in the serverless era? Second, what is low-code? Third, easier application development is not a dream. Fourth, serverless and low-code combined can build a wide range of applications for digital transformation. Let's take a look at the overall challenges in the application development process. Number 1, the service rollout is slower than expected. For example, a CEO expects the application to be developed next week. However, the CTO and CIO say it will take 6 months. Number 2, difficult and complex digitalization takes a long time. Therefore, 42% of CEOs have proposed a digital strategy and 61% plan to increase their investment. Number 3, integration of digital technologies and services is very complex and increases exponentially. We now use digital technologies, for example, big data, IoT, AI, and new video technologies. Moreover, application scenarios are complex, leading to difficult multi-vendor collaboration and integration among enterprises. All these present major challenges for us to adopt technologies in different scenarios. So how about the engineers we need? In fact, current engineers cannot match required capabilities and quantity, and it takes 3 years for a person to master a new technology. Enterprises will never have enough top talent. So the challenge is to enable ordinary people to do extraordinary things. That's the third challenge we're facing. Number 4, software is very complex. There is a gap between software output and workload invested. But why? In fact, the complexity of software, complexity of new technologies, complexity of the software industry, and communication among people are what lead to this gap. Our low-code platform is dedicated to putting complex things into a platform and turning uncertainties into certainties. This is the concept we use to define AppCube, leaving complexity to the platform and simplicity to developers. Just now, we have seen many challenges in the development of software and digitalization. Advisory firms predict that to address these challenges, the low-code platform has entered a rapid upswing period. Forrester proposed the low-code concept in 2014, and Gartner proposed the concept of APaaS in 2018. According to forecasts from Gartner, Forrester, and other well-known advisory firms, the number of people who choose low-code development platforms and the amount of investment will rise significantly. Our low-code platform is in line with these forecasts. From another dimension, let's look at all the software development milestones. At the beginning was the machine language, binary code, and high-level language era. Software development is in the high-level language era and changes from structure-oriented to object-oriented. Software development is in the high-level language era and changes from structure-oriented to object-oriented. In addition, software engineering has changed from waterfall to agile. As such, we can say software development has taken a qualitative leap. So what is our next qualitative leap? In the low-code era, complex content and capabilities are incorporated into the platform to simplify development and accelerate operations development. How do we address these challenges for low-code development? Huawei AppCube low-code platform is a breakthrough for rapid application development and effectively addresses numerous challenges during digital transformation. Let's take a look at its overall architecture. We have an app development platform studio and engine, as shown in the middle of the figure. The logic, models, and applications orchestrated in the studio are text descriptions of logic. These descriptions are packaged and run on the engine. This is similar to the Java architecture, where Java code runs on the JVM. The difference is that it is a JSON packet. We have backend integration and interconnection tools. Serverless supports Huawei Cloud services and function computing. Hundreds of such services, videos, and third-party systems are aggregated on low-code platforms. Then, they can be invoked by our platform on serverless mode through our integration tools. AppCube also provides an O&M platform to ensure system robustness. Huawei Cloud AppCube is a low-code platform driven by metadata and has a service portal. The backend is supported by serverless to solve the challenges brought by application development and digital transformation. So what is low-code and no-code? Huawei Cloud AppCube has low-code and provides developers with a development environment for page orchestration, logic orchestration, and data object build. After orchestration, a text description file is generated. The file is packaged and installed on the runtime base. This is the Huawei Cloud system. AppCube is a one-stop development platform for program orchestration, compilation, test, release, and rollout. Huawei Cloud AppCube provides 5 capabilities. First, the no-code capability to enable service developers to quickly build without writing code. Second, low-code capability for software developers. they can perform most service orchestration and build applications with a small amount of code. In addition, no-code development can be seamlessly converted to low-code and changes the entire operations from shallow to deep. Third, you can develop applications with no code and low code once and release them to multiple types of devices such as mobile phones and computers. Fourth, AppCube provides a replicable mechanism. The developed templates, assets, and APIs can be reused for developers to invoke and to improve development efficiency. And finally, we provide a set of automatic deployment and test pipelines for fast testing and service rollout with developers to build a prosperous them and build applications for various industries. The low-code platform has 4 key capabilities. First, with UI orchestration, you can orchestrate pages, adjust layouts, configure and design colors, and build data models to save the developed application data. Service orchestration logic allows machines to automatically complete transaction-level logic processes. In addition, for processes requiring manual intervention and approval, you can use the BPMN capability. AppCube also provides other capabilities, but we will not cover them today. This is the Huawei Cloud AppCube overview and shows how it enables rapid service innovation. First, we provide the development service. You can orchestrate pages, construct logic, and access microservices. Second, we provide online test services. After the logic description is developed, the logic description is packaged into the test environment for testing. Third, we provide the runtime service. After the test, you can install it in our running environment and roll it out. In addition to these 3 services, AppCube provides connectors and serves as the unified portal. The serverless architecture can integrate Huawei Cloud services, legacy customer databases, and existing digital capabilities. Microservices developed by Full Code can be accessed, registered, and invoked. The asset reuse mechanism allows developers to obtain related component templates, greatly improving efficiency. Huawei Cloud AppCube is based on DevOps and enables rapid service innovation. Let's look at the R&D process. In the low-code and full-code scenarios, the entire lifecycle is built based on the DevOps process, and many tools are provided to support efficiency improvement. For example, in the development and design phases, code is packaged into an asset package and source code package. The asset package will be stored in the test environment and running environment to be installed in the future. The source code package will be archived. After the test environment is installed, services will be automatically tested and deployed with a test pipeline and deployment pipeline. In addition, we provide user environments to support the robust running of the entire platform for higher efficiency. Let's see how we use low-code to quickly develop industry applications. Here are several examples. First, we develop an application using a template, which is for device maintenance and management. When an air conditioner or elevator breaks down, customer service personnel will receive a call. A service ticket will be generated, and the dispatcher will dispatch a maintenance engineer to repair the equipment. After the repair, the customer will provide feedback to the customer personnel to close the process. This is a scenario of equipment maintenance and management. The template can be directly installed and used to implement quick replication. If there are special requirements, we can customize and extend the process. We can also use the template for smoke detection. For example, if there is a fire, the smoke sensor can raise an alarm. You can view the on-site fire situation through cameras in the application, dispatch tickets, send messages, and trigger emergency handling. This scenario requires information configuration, camera configuration, and location configuration. You can roll an application in just 2 minutes. There are other templates for frequently used applications, such as questionnaires. You can use these templates directly. There are also some event-based light templates, which you can use to quickly build health check apps and raffle apps, for example. Finally, let's look at how we can accelerate digitalization and build complex enterprise applications in the serverless era. Let's look at a few cases. digital transformation scenarios are complex, involving many different people. In the lower right corner, application developers are provided with low-code development capabilities. Professional software development engineers can quickly build operation capabilities through some orchestration and a small amount of code. In the lower left corner, experienced software developers understand both services and technologies. They can use industry knowledge and algorithms written in Python or C++ to develop and release services to the platform. In addition, enterprise IT personnel use low-code capabilities to quickly build applications, and service administrators do the same, but based on templates. In a word, professional software developers can quickly build industry applications to solve complex enterprise problems. Non-professional developers can also participate in the digital transformation of our enterprises. It means anyone can be a developer and be a part of digital transformation. What problems does AppCube help developers solve, and which scenarios can it be used in? The platform is built for complex application scenarios. It can be used to develop complex applications in cities, campuses, governments, finance, and manufacturing enterprises. These applications include internal sales management systems, process management systems, and procurement systems. You can also build some large screen applications, including those for command centers and campus IOCs. Some applets can be released to Huawei's WeLink and OneMobile, as well as WeChat, allowing developers to experience them on mobile phones. Huawei Cloud AppCube provides integrated development capabilities. Through the serverless architecture, AppCube can interconnect with systems similar to Huawei Cloud IoT platform. It supports different interfaces of different systems and can interconnect with existing systems through corresponding capabilities. For example, Huawei Cloud connectors have been pre-integrated and pre-developed. Applications can be installed through connectors. After some configurations, these applications can connect to hundreds of applications deployed in Huawei Cloud. We combine AppCube front-end orchestration with serverless back-end support, allowing developers to select many microservices and operations for access. Let's take a look at its adoption in the operations scenario. For example, Cooperating Alliance Decoration uses AppCube as the middle-end platform to manage services, including the decoration process. The development efficiency is increased threefold. Digital Hail has put a large number of 3D components on our platform to build large screens, improving development efficiency more than fivefold. Dalian Xinghan Soft has used our platform to build information management systems. The development efficiency has been improved to varying degrees. iSoft Stone has used our platform to develop industrial enterprise applications and smart campus solutions. It reuses existing platform capabilities and assets, improving development efficiency more than threefold. Today, we have talked about how the low-code development platform addresses the challenges of enterprise digitalization, development, and operations in the serverless scenario. We have many capabilities, tools, platforms, and practices to address these challenges. We hope you can use them and experience them in future work and learning. Thank you.